Okay, good morning, everybody. Hope you guys are doing well. Today I'm going to do I'm going to go over the second part of the section four. I want to just focus on factoring today. There are a ton of different factoring techniques. I'm going to try to show you at least an example of each one, just so the main four that we go over, I should say, just so you're familiar and you'll remember hopefully how to do the various equations that you're going to encounter in this section four. So let's get started. The first example that I want to go over is actually the example that is in this packet. It is partway down through section four. There's section four right there. It's on the second page. And I want to show you how to factor this x squared plus 5x plus 4 equals 0. Now, in my opinion, these are about the easiest ones to factor as far as quadratic trinomials go because there's three terms to it. And so what you're looking for is you're looking for two numbers. You're looking for two numbers that multiply to give you 4, but then also add to give you 5. So we have two choices for 4. 4 can be figured out by doing 2 times 2, which is 4, or 1 times 4, which would also give you 4. But remember, we also need those two numbers to add up to be 5. So out of our choices that we have, 2 and 2 or 1 and 4, the ones that will add up to be 5 are going to be the second one. So those are the two numbers we need. And so we'll just do plus 1 and plus 4. And that one is factored. So that's the easiest way to factor these types of equations. Now, one thing to keep in mind, this is a quadratic trinomial. Quadratic means it is a squared. The trinomial part means it has three separate terms. Now, what allows us to factor it like that and not go through the ABC method is the fact that this x squared term has a 1 in front of it. It's just 1x squared. If that was a 2x squared or something else like that, we would need to use the ABC method. So let me show you how the ABC method works. I'm going to scroll down here a little bit. Um, and I'm going to do one of the problems from this homework set, which is this one, number 36. Um, so I want to do 36 for you. Now, a couple things to keep in mind. The very first thing that you should ever try to do when you're given any equation to factor is to try to take a GCF out. That can really make these problems a lot easier if there's a common factor that needs to be factored out first, because it'll make all your numbers and all your variable degrees smaller and make them easier to work with. So looking at 2x squared minus 5x minus 25, we look at the first, it has a 2, the second one has a 5. So 2 and 5, they're what we call relatively prime. There is no number that you can factor out of that. So the next thing we want to look at is, could I just do what I did in that last example problem I showed you? And the answer, unfortunately, is no. And the reason why it's no is that number 2 right there. So because there's a number 2 right there, we need to do what we call the ABC method, which is to take the first number and multiply by the last number, and we get negative 50. Now, why do we got to do that? Well, we now need to go through negative 50 and write down all the factors of negative 50. So I always start with the smallest and work up. So 1 and 50, 2 and 25, 3 will not go into 50, 4 will not go into 50, 5 will, 5 and 10, 6 won't go in, 7 won't go in, 8 won't go in, 9 won't go in, and then we're to 10. So now that's it. So we've got our three sets of factors of 50. And what we have to do is figure out which one of those pairs of numbers, either this pair, this pair, this pair, which pair will add up to be negative 5. Now keep in mind, it needs to equal negative 50 when they multiply. So that means one of these numbers that I have the arrows drawn beside has to be positive and one has to be negative. So, but they also need to add up to be negative 5. And the only choice we have here is this last choice right here. So if we want those to add up to be -5, if I would arrange those so it's +5 and -10, we will meet both of our requirements. Remember, our requirements, they have to multiply to be -50, and they have to add to be -5. And -10 and 5 do that. So now what we do is, because this is the ABC method, is we have to split that center term. So we have 2x squared plus 5x minus 10x minus 25 equals 0. So now we have four terms. We have 2x squared plus 5x minus 10x minus 25. And what we do to the next step of the ABC method is to group the first two terms and then group the second two terms like that. And we have to pull out the GCF. And the GCF in the first grouping is an x. So we pull an x out and we're left with 2x plus 5. The second one, we're going to pull out a -5, and we're going to be left with 2x minus 5 equals 0. Now, by pulling the GCF out of each of those, so the first one had a GCF of x, the second one had a GCF of -5, we end up with something. We end up with 2x plus 5 here, and we should have ended up with 2x plus 5 right there as well. And those two things have to be the same. If they're not the same, you can't continue. Now, once we know those are both the same, you just proceed to regroup. So you have x minus 5 here, and then you have 2x plus 5 there. You only rewrite one of the 2x plus 5s. From there, we're going to set each part equal to 0. So x minus 5 equals 0. That means x is 5. And over here, 2x plus 5 equals 0. 2x equals -5. X equals -5 over 2. And so there's one solution, and there's the other solution. Let me move this out of the way so you can see that. All right, so that was, again, that was called the ABC method. So the trick to the ABC method is to multiply the first number times the last number, write down the pairs of factors, find the factor that will work so you can split that center term. Once you've split that center term, you group the first two and group the last two, take out the GCF, regroup, and then solve your equation. And you will use that method anytime you have three terms and your first term, the x squared term, has a number other than 1. In this case, it had a 2. All right, so I want to show you a couple more. The next one I want to show you, I want to go up here to this example, go back up for a second. This one asks you in the second part to solve the following quadratic equation by factoring. Now, as I said before I started the last problem, anytime you're asked to solve by factoring, the first thing that you want to do is to try to take a GCF out. Always. That is number one step. So if you look through this particular equation, -3x squared plus 12x equals 0, you can see that they do have common factors. They're both divisible by 3, and they're both divisible by a single x. So we're going to take both of those out. Now, since the lead coefficient is negative, I'm actually going to take a -3x out, as you can see we did right there. And then once I take a -3x out of this expression, I'm left with x minus 4. And the way you do that is -3x squared divided by -3x. -3 divided by -3 is 1, and x squared divided by x is x. So you can see we're left with a 1x right there. This 12x divided by -3x, 12 divided by -3 is -4, and x divided by x is 1, so we don't put anything there. So what you can see is we took this original expression up there, took out the GCF, which was -3x, and we're left with x minus 4. Now, the key thing to remember is if I took this and I distribute it back to this and this, you would get the original equation. Now, from there, once you've taken that out, you've gotten that split into two different things that are multiplying. You can split each of these and set each of these parts equal to 0 individually, which is what they did there, and then they solved and got x equals 0 and x equals 4. Okay, so that was a fairly straightforward one as far as just taking GCF out. There's two more that I want to show you, and they're down towards the bottom. I want to show you how to do number 30, and I want to show you how to do number 31. 30 is a little different because 30 involves having four different terms. One, two, three, four. So the strategy to having four terms is anytime you have four terms, you're going to try to group. So you're going to group the first two. I'm going to make that plus a negative x there, and I'm going to group the second two. And then you're just going to simply take the GCF out. So in the first one, the GCF is going to be 3x squared. Notice the first one is x cubed, the second one's x squared, which means they both can have an x squared taken out of them. So we're going to take a 3x squared out, and I'm going to be left with x plus 4. And then the second one, there's really not a GCF other than -1. So I'm going to take a -1 out, and I'm going to be left with x plus 4. Now, again, the key thing to keep in mind, once you group those four terms together and you take the GCF out, what you're left with here and here needs to match. If that does not match, you can't proceed to the next step. The next step involves regrouping. So you have 3x squared minus 1. You take the two numbers, the GCFs, you group them, and then you only write one of the grouped parts that are the same. Now that that's broken up, to solve, you're going to set each part equal to 0. And the first one is easy. X plus 4 equals 0. That means x equals -4. So there's my first. If I can get that negative to work, there's my first one, x equals -4. The second one, maybe not so much. It's a little trickier. 3x squared minus 1 equals 0. 3x squared equals 1. X squared equals 1/3. And when I take a square root of that, x equals the positive or negative square root of 1/3. But we can't leave it like that because the square root is over the 3 on the bottom. So we're going to take the square root of 1, which is 1. This leaves us with plus or minus 1 over the square root of 3. But then we need to multiply that thing by on the top and the bottom by the square root of 3 to rationalize it. And so our final answer that we'll get is plus or minus root 3 over 3. And that is actually two more answers. So there ends up being three solutions to that equation in all. The first one is -4, as you can see up there, and then the second two are plus and minus root 3. Now, the last one we're going to do is going to be a special case scenario, this right here, this x cubed minus 64. So you may or may not have recognized this, but this is a difference of two perfect cubes. So last year you would have been given a formula to be able to factor these. I'm going to write that formula down for you. The formula consists of this: u cubed plus v cubed is equal to u plus v, u squared minus uv plus v squared. So that's for the sum of cubes. This is going to be for the difference of cubes. So that's u cubed minus v cubed. It's going to be u minus v, u squared plus uv plus v squared. So those two formulas are going to be what you need to use anytime that you have a sum or a difference of cubes. So let me show you how to use one of those formulas. You can see obviously x is being cubed. That makes sense, right? So then there's a 4 there, but we need to rewrite that. So this needs to be rewritten as x cubed minus 4 cubed. right? Because 4 times 4 is 16, 16 times 4 is 64. So now it's just a matter of recognizing which what goes in where in the variables of the equations. So this x, everywhere where there's an x, well, let me back up. This is a difference of cubes, so we're going to be using this equation. But that x, everywhere where there's an x, that's going to go in for your u. So that's going to go here, 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 here. Everywhere where there's a v, that's where the 4 is going to go. Because you can see right here, what I'm underlining, that's u cubed minus v cubed. That's what we have here. X cubed minus 4 cubed. So it's going to fit with this equation. So in this whole part right here, let's put in our variables. So x goes where u is and 4 goes where v is. So I'm going to do that. I'm going to have x minus 4, and then I'm going to have x squared plus x4 plus 4 squared. Now the last thing we need to do is just clean this up a little bit. The x minus 4 stays the same. The x squared is going to stay the same. We're going to rewrite this as plus 4x plus 16, and we're going to leave that as our final answer like that. Let me move that so you can see. So that's how you do a sum or a difference of cubes. You went over it last year, but it's obviously been quite a long time. So I wanted to make sure I hit that. So if you have any other questions on this, feel free to email me. As we've always done, tomorrow's going to be a in-person live session. I expect there's probably going to be some questions on this, and this is okay. This stuff is pretty challenging, especially the factoring stuff, especially. So, all right, guys, have a good day. I'll see you tomorrow.